Today we're going to learn about radio waves and how they are transmitted. On the next right side in your notebook, following your electromagnetic spectrum notes, you're going to take notes today on radio communication. This should be roughly around page 47, give or take, depending on where you are in your notebook, but just make sure this follows the electromagnetic spectrum notes. Some things to remember to make sure to include in your notes are a definition or location of radio waves, what they're used for, how they transmit the waves, and then information about AM and FM modulation, which you'll see when we get there. So to tell you what radio waves are, we've already talked about them a little bit when we went over the electromagnetic spectrum. You know that they are found on this spectrum and they're at the far end. They have really long wavelengths, so there's a big distance between one wave to the next. They have really small frequencies and low energy. They transmit information over short distances to your TV and radios. And radio waves, while they're useful for communicating, they are not harmful. So how do radios send information? There are a couple key things that you need to remember when we are thinking about radio transmission. The way that a radio works is in order for it to send the waves, it has to have a transmitting antenna. So it has to have an antenna that transmits the signal. It sends it out as a radio wave at a certain frequency. That frequency is what tells us the size of the wave, and then it's picked up by a receiving antenna. So if you see this picture over here, this is a good picture to include in your notes. You see that there's a transmitter. What transmitters do is they have something in them that causes them to change the current and the frequency at which it's sent out. So those waves are transmitted through the air. And then a radio receiver actually picks it up, and that's why you're able to hear sound. So these radio waves are coming out of a transmitter. Your radio is receiving it and picking it up, and then you're able to hear what is on the radio. So how do radios work? What I need for you to do is on the left side of your notebook, roughly page 46, I want you to record 3 things that you learned from this video about how radio waves work.
Good grammar and spelling are important, but if you want to write essays that inspire, message. How does a radio work? The longest waves on the electromagnetic spectrum, radio waves, carry information from a station to a receiver. But radio waves don't carry information all by themselves. They need to be altered or modulated. A signal, a transverse sound wave, overlays the carrier wave, forcing it to change. There are 2 ways radio stations modulate their carrier waves: amplitude modulation, or AM, and frequency modulation, FM. AM radio broadcasts a carrier wave that maintains a constant frequency, while the overlaying sound wave modulates its amplitude. And FM radio maintains a constant amplitude, while the frequency varies based on the overlaid signal. AM and FM radio carry sound waves, a type of analog signal, to your receiver. Modern digital radio carries information as a digital signal, coded in the form of numbers. Millions of radio waves carrying sound wave signals and digital signals reach your receiver every second. The receiver's tuner picks out a specific signal. Its amplifier strengthens that signal. A demodulator separates the signal from the carrier wave. And then a speaker converts the signal to the sound waves that you hear.
All right, so a little bit of what you learned in that video. You learned about radio waves and how they're transmitted. You learned that in order for waves to be transmitted, they have to be changed. And so now we're going to look at AM modulation and FM modulation and what that means exactly when those types of waves are transmitted. as you heard in the video, radio stations, they transmit signals by changing a radio wave's amplitude or their frequency. Remember, amplitude refers to the height of the wave. Frequency refers to how frequent or how many waves you have occurring in a given cycle. So on the top up here, if this top line is the signal, AM waves, you can see that the amplitude changes. FM waves, you've got the frequency changes. Okay, so that's a good picture to include in your notes, and now we're going to look at each one individually. So let's start with AM radio waves. So if you've ever played around on a radio, you know that it has an AM and an FM setting. AM radio waves stand for amplitude modulation. You will see those again, so make sure you know the name of that. The definition of AM radio waves is that it is a method of broadcasting signals that changes the amplitude of the wave. So it is a matter of changing the amplitude in order to broadcast the wave itself. AM waves or AM signals, they travel as changes or modulations in the amplitude. So again, with AM radio waves, the amplitude changes. While the amplitude changes, the frequency is constant, meaning it does not change. And generally, when we think of AM waves, they have long wavelengths, low frequency, low energy. And one big important thing is if you look at the picture here, they are reflected back to the Earth's surface by the Earth's ionosphere. So the ionosphere is this protective layer that is in the atmosphere. And when these waves hit it, they are reflected. So reflected, remember, means they bounce off of it and they come back. And that's how they're broadcasted over long distances. If you've ever been playing on the radio as a kid, I know I did, AM radio waves, sometimes you can pick up some like overseas channels or you can pick up foreign things. It's the one that it sounds a little bit more fuzzy. AM radio waves travel farther, so they can be broadcast over longer distances than FM radio waves, which we'll talk about in just a minute. But remember, with AM radio waves, AM means that you are modulating or changing the amplitude. And again, these waves are reflected by the ionosphere. You'll see that again. So include this picture in your notes when you're recording your notes on AM modulation. So taking us to FM waves, if AM causes a change in the amplitude, FM causes a change in the frequency of a wave. So this is just a method of broadcasting signals by changing the frequency of the wave. What happens is, again, FM signals travel as changes or modulations in the frequency of a wave. So like you saw in the video, you have your signal, and then these carrier waves, the frequency is changed in order for it to be broadcasted. So with FM waves, again, the amplitude is constant and the frequency is changing. They tend to have higher frequencies and a little bit more energy than AM waves. And the thing is with them, when it comes to the ionosphere, so if you see this picture here, another picture I want you to include in your notes, FM waves pass through the ionosphere, so they don't get reflected off like AM does. And because of that, that means they don't travel as far. So they don't go as far as distances. They also produce better sound quality. So these are the stations that you hear on the radio that are more your local stations. If you notice, if let's say you're listening to a local station and you travel out of the city, eventually you're going to lose that station because those waves cannot travel that far. So FM waves, they pass through the ionosphere, so they are transmitted, but they are not reflected back to Earth like AM waves. So therefore, FM waves do not travel as far, and they do have the better sound quality. FM tends to be what we listen to when we are listening to the radio. So when we're talking about AM and FM waves, and we're talking about radio transmission, is there anything that can interfere with waves? Well, instantly your instinct should go back to wave interference. We talked about a couple of those types when we talked about wave behaviors. So the answer is yes. There are some materials that can block or interfere with radio waves. For example, materials that are electrically conductive metals, they can reflect or absorb radio waves and interfere with their transmission. When we talk about wave transmission in general, there are other objects that can also block or get in the way of transmission. let me go back to that previous screen. So like, for example, in this picture down here, if we were talking about TV waves, it's the same for radio waves. That signal's going out, and you can see that this boulder or whatever it is in the way. So it's interfering. So some materials, yes, they can interfere with waves being transmitted from one resource to another. And when we talk about radio waves, they are used for communication in lots of ways, not just for us to listen to the radio to get our news or music, those kinds of things. Taxi and police radios, they are assigned separate sets of frequencies. So why would they be assigned separate frequencies if they're using the radio waves? Well, the answer is because you wouldn't want those stations to interfere with one another. Police radios need to be more private. They need to be so that they're not interfering with other people. Police radios need their information kept confidential. You wouldn't want that information being leaked somehow to someone else. Taxis, same thing. If they're picking up people and they're getting calls in, they don't want to get their lines crossed because that can mess up things with knowing who to pick up and where to go and those kinds of things. Amateur radio frequencies are assigned for people who operate radios as a hobby because they don't interfere with each other. So they're, people that have their own radio stations or local stations or have some kind of hobby where they do things over the air. They have their own frequencies as well because that helps keep things from interfering. And that is it. Those are your notes on radio communication. So I hope that you learned a little bit. Make sure you know the difference between AM and FM radio modulation and that you know that radios have to have a transmitter and a receiving antenna. When you're finished, don't forget to complete the exit ticket for today from Canvas.